Okay, I want us to take a look at some additional examples of identifying the type of data you have. So many of you seem to be having difficulty with this particular concept or this particular problem. So, one of the things that I tried to do to maybe help you out is I created a flow chart or kind of a decision tree to help you make a decision. And you start out by asking yourself, what kind of responses do you have? Do you have words or phrases? Do you have numbers with which we do not calculate or numbers which we do calculate with? And then it walks you through. So I want to go through some examples together and show you how to use this flow chart to ultimately achieve or get to the correct answer. Okay, so our first one says the number of family members living in your home. So I want to ask myself, if I were to walk up to you and say, how many family members live in your home? What kind of response would you give me? Well, most likely you're going to say something like 3, 4, 5. Okay, so you're going to say something 3, 4, 2, maybe just 1. Okay, so notice that those are numbers. So then you want to think about, so if you know that it's numbers, then you have to decide, is it numbers that you're going to calculate with or not? So then you want to think about it. Would it be, would you think about adding together the number of family members from your results, or would you multiply them or divide them? And so we could calculate. So I'm down to the decision that I believe these are numbers with which we calculate. So then I need to decide, is it going to be whole numbers, or is it a measurement where I could have part of a family member in this case? Well, despite the government's thought that you can have part of a person, okay, you really can't. So you're telling me 3, 4, 2, those are whole units or counts. Okay, the other phrase that jumps out at me here too is number of, which again gives that sense of counting. Okay, so now I'm thinking, okay, so we've said we think the kind of responses are numbers with which we calculate. I believe they're discrete because we're counting and it's wholes. And so then the next step is I have to decide, what would 0 mean? What would it mean if I had 0 family members living in your home? Okay. Does 0 mean none, or is it just a random starting point? Well, 0, if I say I have 0 family members living in my home, that would imply I have none of them. So I would have quantitative discrete. Okay, the red diamonds give you your ultimate result. Quantitative discrete, and it's at the ratio level of measurement. All right, the next one. The ages in years of family members living in your home. So again, you want to think about it. If I were to walk up to you and say, how old are the people who live in your home? Okay, you may say things like 50, 47, 11. Okay, so again, you're giving me numbers, and so you want to think about, would we calculate with numbers? Could we, for example, find the average age of the people living in your home? And the answer would be yes. So again, we have numbers with which we calculate. Then you want to think about, are you going to give me a whole unit, or are you going to give me, is it some sort of measurement? Now, again, typically you have to think about the context here. And it even says in years. So when you respond, you're just going to give me the years. You're not going to say, 50 years, 4 months, and 5 days old. We simply say we're 50 years old. We don't go into the months or dates. So it is discrete, okay, because it is a whole number. We're not adding in a partial or anything. We don't really usually say we're 50 and 3/4. Okay, then we want to think about what 0 means. Okay, that's the next step. So I've decided it's quantitative, discrete, and then I have to think about what 0 means. And so again, it may seem a little weird, but think about it. If a person is 0 years old, at least in my mind, that implies they do not exist. They don't exist. So you would have nothing, and if you have nothing, that makes it the ratio level. Okay, so the ages in years would be considered ratio. So ultimately, the ages in years of your family members is quantitative. It's obviously a number. It's discrete because it's a whole number, and it's at the ratio level of measurement. Next, the color of your home. So again, think about, as you begin thinking about the flow chart, think about what kind of response would you get? What if I come up to you and I say, what color is your house? You're going to say things like maybe red, yellow, blue, white. Okay, again, you're giving me words. You're not giving me numbers. So we get words or phrases, which then tells us that it is qualitative. If it's qualitative, then we got to think about, do those words or phrases have a sense of order or ranking? Is it better to live in a red house than a yellow house? Or is it better to live in a yellow house than a blue house? And honestly, there's really no sense of order there. I mean, one color is not necessarily better than another. So we would say no, which puts us at the nominal level. So ultimately, we've decided that the color would be qualitative because it's words, and it's at the nominal level because one color is not necessarily better than another. All right, the height of family members living in your home. The height of family members living in your home. So again, think about the question and what kind of responses you would get. Okay, so if I walked up to you and said, how tall are your family members? You might say something like they're 5'6". You could say they're 4'11". You might say you might even say, if it's a small infant, you might say something like they're 20 inches long, because we typically measure babies' lengths in inches. Okay, so you're going to get, again, you're getting numbers. Okay, so that rules out words or phrases. So then I have to think about, with numbers, am I going to calculate with these numbers? Could we find the average height of your family members? Or could we think about maybe who's taller or who's shorter? How much taller is one person than another? And we can. So we have numbers with which we would calculate. Okay. Then you have to decide. So then we need to decide, we know it's quantitative because it's numbers. Is it discrete or continuous? Well, we're getting 5 feet, 6 inches. So you're getting parts of a foot, part of an inch, if it were small. So that's a measurement, which means it's going to be continuous. Anytime you're using some sort of measuring tool, you're going to have continuous, because you could have parts of a unit. And then again, we have to decide what 0 means. Okay, so think about it. What would it mean if we said someone was 0 inches tall? Okay, well, if they're 0 inches tall, that means you have no person or no one. Okay, so that means none. So you would have ratio. So ultimately, we've decided that the height is quantitative. It's a number. It's continuous because it's a measurement and you can have part of a foot or part of an inch. And it's at the ratio level. Next, IQ scores of your family members living in your home. So again, think about what kind of responses you would get if someone comes up to you and says, "What's your IQ?" or "What's the IQ of your family members?" You're going to get numbers like 80, 120, 130, 90. Typically, they're in terms of powers of 10. I don't think you get decimals. So again, notice you're getting a number, so that rules out words or phrases. So you want to think about could we calculate, say, the average, or could we determine the highest age, the lowest age? And we can. So again, we have numbers with which we can calculate. And there's probably some debate here. When they report the results are actually usually stated as whole numbers. So contextually, you have whole numbers, but you're also using an instrument, the test, to determine the score. So you could kind of go either way. But in the context, they're listed as discrete, okay, because they're whole numbers. So I'm going to go with quantitative discrete. And then I want to think about what zero means. To think about what zero means, zero, it doesn't make sense to say that zero means you have no IQ or no brain. Okay, that doesn't make sense. That's like crazy. Okay, so in this case, the zero is simply a placeholder. It's where they began scoring the test. Okay, so IQ scores are at the interval level. Okay, it's just a random starting point. Okay, so we've decided that IQ scores are quantitative, they're numbers. Contextually, looking at the context, they're discrete because we have whole numbers. It's at the interval level because the zero is simply a random starting point. Right, next, the area in square feet of your home. So if I were to say to you, what is the square footage of your home, you got to think about what you might get. So for example, it might be that someone says the square footage of my home is 1,352 square feet. It might be that they say it's 2,500 square feet. If you got somebody who's really well off, it might be more like, 4,250 square feet. Okay, so you're getting numbers, so that rules out words or phrases. Thinking about, would you calculate with that? Could we again maybe find the average size of a home? Could we find the largest? Could we compare and say this house is bigger than that house? And the answer is yes, so we do calculate with that. So it's numbers with which we calculate. Again, in this case, it's really a measurement. Now, the examples that I gave you are whole numbers, but we're really measuring because you would measure, we would say the house, it could be a fraction or a decimal, so it is continuous. It's associated with a measurement. Thinking about what zero means, if I say my house is 0 square foot, that does mean that I have no house or no area. Okay, and if I have no area, I have no house. So again, in this case, it represents ratio. 0 would imply none. So we ultimately decided that area is quantitative. It is definitely a number. It is continuous because it's on a measurement scale, and it's at the ratio level of measurement. All right, the next one. Car manufacturer, Ford, Kia, Chevy, driven by family members in your home. So again, think about the question. The question would be, what kind of car do you drive? And your response would be something along the lines of Ford, Chevy, Kia, Toyota, Hyundai, Honda. Okay, something along those lines. And notice you're getting words or phrases. So that takes me over to words and phrases. That's pretty easy. So that makes it qualitative. And then you want to think about, do the words or phrases have a sense of order? You know, is driving a Kia better than driving a Chevy? Or is driving a Chevy better than driving a Toyota? Now, that could be debatable, but overall, the answer is no. One is not necessarily better than the other, which makes it nominal. So we've decided that the car manufacturer would be qualitative and it would be nominal. Okay. Social security numbers of your family members living in your home. Well, it's kind of in the name here, guys. Social security numbers. It is numbers. Okay. So it's not words or phrases. But think about it. Would we, if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, if that were a social security number, and you had a bunch of those, maybe we had 9, 8, 7, 6, 5, 4, 3, 2, 1. I mean, we've got two social security numbers there, but are we going to add those together? Are we going to subtract them? That kind of stuff. No, we don't normally calculate with social security numbers. So these are numbers, yes, but they're numbers and we don't calculate with them. It's simply a way that the government tracks you. It's almost like a label. Okay, it's like a label. So because it's a label and we don't calculate with it, it's actually considered qualitative data. Okay, and then do they have a sense of order? Well, I mean, if you look at the numbers, there does seem to be a sense of order, but the numbers are just random, so there's really no sense of order here. So again, it's still going to be simply at the nominal level. So Social Security numbers, although they're numbers, are actually qualitative because they're just being used as labels, kind of to track. Think about it like a tracking system. And it's at the nominal level. There's not a sense of ranking to them. Okay, the birth year of family members living in your home. Again, think about the response you would get. If you walked up to someone and said, what year were you born? You might have values like 1968, 1971, 2007. Again, you're getting numbers, okay? So it's definitely not words or phrases. So I have numbers. And could we calculate with those? Could we say, one person is 3 years older than another? Or there's, one is, born 20 years after or 30 years after. And we can. So we can actually perform calculations with these. Okay. So, and notice they're whole units. We don't say I was born in 1968.8, okay, or 1971.3. Okay, it's a whole number, so it's discrete. And then again, you got to think about what 0 means. And so again, think about what it would mean to say, I was born in year 0. Okay, year 0 does not in any way mean there was no year, okay, or that nothing happened. It's just the place where at some point humanity started counting and marking off the years. So we're at the interval level of measurement. Okay, and that's typically true of most kind of dates or years. It's going to be quantitative. It is discrete. Years are usually stated in terms of whole numbers, and it's at the interval level of measurement. All right, the number of televisions in your home. So again, think about what kind of results you would get if you walked up to somebody and said, how many TVs do you have? It might be that you say, we have 4 TVs, or we have 1 TV, or we have 2 TVs. So again, you're getting numbers. So that rules out words or phrases. Then you want to think about it. Could we say, okay, Susie has 2 more than Johnny? Could we find an average? We could say that average number of TVs in a home are such and such. Okay, so it is numbers we can calculate with. Again, notice when you're getting answers, you're getting whole units. We don't really say we have 2.5 TVs or 3.25 TVs. So again, you're getting whole units. Because you're getting whole units, that makes it quantitative discrete. And then you want to think about what it means to say there are 0 TVs in my home. If you say there are 0 TVs in your home, that means there are none, which puts us at the ratio level of measurement. So we have ultimately decided that the number of televisions is quantitative. Again, it's a big giveaway when the description says number of, that you're going to have numbers. It's a discrete. And typically, if you're saying number of, it's also going to be discrete. And then it's at the ratio level of measurement. Sizes of shirts: small, medium, large, so forth, worn by family members in your home. So again, if I walked up to you and I said, well, what size shirt does your husband wear? What size shirt does your child wear? Again, you're going to give me something like small, medium, or large, extra large, whatever. So again, you're giving me words or phrases. Okay, you're giving me words or phrases. And if I have words or phrases, then my data is definitely qualitative. And so then I want to think about, is there a sense of order here? Well, when you're talking about shirt sizes, there is a sense of order, because small would be the lowest level, then medium, then large, then extra large, then 2X and 3X. So there is a sense of order or rankings there if you rank them low to high. So we have to say, yes, there is a sense of order, which makes it ordinal. So we've decided that shirt sizes are qualitative and it's at the ordinal level of measurement. Ordinal has that almost the word order in it. So it's what you call it when you have that sense of order. Couple more. The last grade completed by family members in your home. So if I walk up to you and I say, what was the last grade that your husband completed? So you might say 12th grade. What grade has your last grade your child's completed? You might say 4th grade. You might even say that they're college grad. So college, could say it's 16th. It's not really a grade, but you get the idea. So again, you're getting numbers, okay? But So it's not words and phrases. You're getting numbers, but normally we wouldn't necessarily calculate with the grades, okay? Grade levels, we would just say, one went further than another. So it's not really numbers we calculate with. So that gets us back over into the qualitative range, okay? And then you want to think about, do you have a sense of order? And there is a sense of order here, guys, because we know pre-K comes first, then kindergarten, first grade, second grade, third grade, and so forth. There is a sense of order to it. So we would have to say, yes, there is a sense of order. Because there's a sense of order, it is ordinal. So the last grade completed by your family members would be qualitative. It's just a label, even though some of the responses may be numbers, and it is ordinal. Okay, there is a sense of order. All right, finally, the license plate of vehicles driven by family members in your home. Okay, so license plates typically have some letters, some numbers. It might be something like, say, GHC 2019 could be a license plate number. It might be like BR 5847. Okay, so you can have letters and numbers. So you kind of got a combination going on there. Okay, so you kind of have some words, phrases, letters, but again, in terms of the numbers, think about, would you calculate with the numbers? So either way, how you look at it, really, because it's a combination of letters and numbers, we know we can't calculate with it. So we're kind of limited then. It almost draws you to, regardless of which way you look at it, it draws you back into, it's just a label. It's how the state patrol or the government tracks your particular vehicle. And so then again, you want to think about, do you have a sense of order there? Is one license plate better than another, or one ranking better than another? And it's not. It's just however you come in and go to the DMV to get your license plate. So ultimately, the license plate is qualitative, and it's at the nominal level of measurement. Okay, and I believe I've got one more. The shoe sizes of family members living in your home. So again, think about what kind of responses you might get. You might get size 11. You might get, say, 9.5. You might get, say, a size 4. So again, you're getting numbers. And if you want to think about it, could we calculate? Could we find the average shoe size? I suppose we could. So this is kind of one of those that could be kind of tricky, because you could kind of go either way. It might just be a label and we don't calculate with it, but then we could find an average shoe size. So if you're thinking about finding that average shoe size, it is numbers that you can calculate with. So you could go the route to be numbers that we calculate with, which makes it quantitative. To some degree, shoe sizes, again, it's a little bit in that gray area, but you can have halves or parts because you're measuring someone's feet. So I would go with quantitative continuous. I mean, we don't sell like 9 3/4 size shoes, but somebody's foot could be that big and they have to go up a size. Okay, so then you want to think about what 0 means. And again, 0 in this case to me would be that kind of like you didn't have foot, okay, because you had to have that measuring point, So I would say it's at the ratio level. Okay, but an argument could be made. Some people might say, well, it's just a label, which makes it qualitative, and it's ordinal because there is a sense of order to the shoe sizes. One size 4 is definitely smaller than 9.5. So sometimes you have data that's kind of in a gray area, and so then you just choose which one you think is best, and be ready to defend that, or say to somebody, well, here's why I think this is the case. Okay, but that doesn't occur terribly, terribly often. So shoe sizes, I'm saying, is quantitative, continuous, and it gets to the ratio level. But somebody else could argue that it's actually qualitative and ordinal.